What if I told you that the most dangerous part of going to the moon isn't the launch, it's the last 20 minutes of the return? Right now, as you watch this, four astronauts are preparing for a mission that defies the safety logic of the last 50 years. They are about to ride a fireball moving at 25,000 miles per hour, relying on a heat shield that, just 3 years ago, did something that terrified NASA engineers. This isn't just a test flight. This is the first time in history humans will attempt a re-entry maneuver that usually belongs to skipping stones on a lake. If the angle is off by a fraction of a degree, they don't come home. And the scariest part? The computer models that predicted this shield would work were wrong before. Let's go back to December 2022. When the uncrewed Artemis I mission returned to Earth, the splashdown looked perfect on TV. But when engineers hauled the capsule onto the USS Portland recovery ship, they froze. The heat shield hadn't just burned, it had shattered. Huge chunks of the protective avcoat material were missing. It looked like a cookie that had crumbled in the oven. Engineers call them divots, concave craters where the material literally popped off. And here is the impossible fact, the supercomputer simulations, which ran millions of scenarios, didn't predict this. Not once. Now, in 2026, NASA is putting 4 human beings, Reid Wiseman, Victor Glover, Christina Koch, and Jeremy Hansen, inside that same capsule design. This is the figure 8 of fire. Artemis II will take these 4 humans further from Earth than any human has ever traveled, 4,600 miles beyond the dark side of the moon. If something goes wrong out there, there is no quick return. Gravity takes 10 days to bring you home. The question is, have we fixed the shield? Or are we rolling the dice on the biggest gamble since Apollo 13? To understand the gamble, we have to look at the machine. This is the Space Launch System, or SLS. It is the most powerful rocket NASA has ever built, generating 8.8 million pounds of thrust. That's 15% more power than the Saturn V that took Armstrong to the moon. Unlike the International Space Station, which circles comfortably just 250 miles up, Artemis II is a free return mission. Here is how the next 10 days will go. The crew will launch from Florida, circle Earth twice to check life support systems, and then fire the main engine to perform a translunar injection. This is where things get strange. They aren't landing. They aren't even entering lunar orbit to stay. They are doing a flyby. Gravity will grab the spacecraft, whip it around the far side of the moon, and fling it back toward Earth like a boomerang. It sounds simple. It's exactly the physics that saved Apollo 13. But there is a catch. The Orion capsule is massive compared to Apollo. It's heavier, wider, and carries much more energy. When it comes back to Earth, it won't be entering like a normal spaceship. If you dive straight in at 25,000 miles per hour, the G-forces would be brutal, up to 12 gs, and the heat would be unmanageable. So, for the first time with humans on board, NASA is attempting the skip entry. Imagine throwing a flat stone across a pond. If you throw it at the perfect angle, it skips. NASA is going to do that with a 23,000-pound spaceship. They are going to hit the atmosphere, bounce off it back into space to cool down, and then dive back in for the landing. It's elegant. It's brilliant. And if they mess it up, the capsule will bounce too high and drift into deep space forever. I'm about to reveal the hidden permeability flaw that caused the shield to crack, and the terrifying storm shelter protocol for radiation. But if you want to understand the future of humanity without the rocket science headache, hit that subscribe button. We decode the universe every week, and you don't want to miss our upcoming deep dive on the Starship HLS. Is it ready? The mystery of the heat shield started the moment Artemis I touched the water. For 2 years, NASA investigated the divots. They built exact replicas of the shield and blasted them with plasma torches in the Arc Jet facility at Ames Research Center. And what they found was disturbing. The problem wasn't the heat. It was the gas. The shield is made of a material called avcoat. It's an ablative shield. It works by burning away. As it heats up, it turns into gas, carrying the heat away from the ship. But on Artemis I, the trajectory was too efficient. The skip entry maneuver created a strange thermal environment. The heat didn't come in one big pulse, it came in waves. Here is the detective work: the avcoat material wasn't permeable enough. When the material heated up, it generated gas inside the solid block. But that gas couldn't escape fast enough. Pressure built up inside the shield until it literally exploded from the inside out, blowing chunks of the shield off into the plasma stream. NASA calls this a permeability mismatch. I call it a ticking time bomb. For Commander Reid Wiseman and his crew, this news was complicating. NASA had a choice: strip the shield off and rebuild the entire capsule, delaying the mission to 2027, or change the way they fly. They decided that the shield is safe, as long as the chunks don't get too big. They are betting that the char loss won't eat all the way through to the metal skin. This brings us to the reveal: the skip re-entry physics. Why risk this skipping maneuver if the heat shield is fragile? Why not just dive straight in? Because of precision. Apollo capsules were dumb. They fell where physics told them to fall. The Navy had to deploy entire carrier fleets to find them. Orion is smart. By skipping out of the atmosphere, the capsule can effectively fly. It uses the lift generated by its shape to extend its range. It can fly 3,000 miles downrange during the bounce. This allows Orion to land right off the coast of San Diego, within sight of the recovery ship. It also saves the crew's bodies. A direct entry hits you with 7 to 12 gs. It crushes your chest. The skip entry splits that force into two bumps of about 4 gs each. It's a smoother ride. But here is the irony: the maneuver designed to keep the crew safe, the skip, is the exact same maneuver that caused the heat shield to crack, the thermal wave. NASA engineers have spent the last 18 months tweaking the angle of attack, changing the tilt of the capsule by mere degrees, to try and stop the gas from exploding the shield again. But fire isn't the only invisible killer on this trip. Just when you thought the atmosphere was the boss battle, let's talk about the Van Allen belts. Earth is surrounded by two giant donuts of trapped radiation, protons and electrons caught by our magnetic field. The ISS flies under them. Artemis II has to fly through them. Twice. This will be the highest radiation dose humans have received since 1972. And unlike Apollo, which sipped through the belts in minutes, Artemis II is taking a hybrid trajectory that spends hours near the danger zone during the initial orbit checks. What happens if the sun decides to sneeze? If a solar flare or coronal mass ejection hits while they are in deep space, the Orion hull isn't enough. NASA has developed the storm shelter protocol. The crew will have to unstrap, float to the center of the capsule, and physically build a fort out of their stowage bags, food, water, and equipment. Water is excellent at blocking radiation. They would have to huddle inside this pillow fort for up to 24 hours, waiting for the solar storm to pass. But they won't be naked. They will be testing the Astrorad vest. Developed by an Israeli company, this vest is made of high-density polyethylene. It's designed to protect specifically the stem cell-rich organs, bone marrow, lungs, breast tissue. If these vests work on Artemis II, they will be the standard uniform for the trip to Mars in the 2030s. So, here is the question. We are taking huge risks: new heat shield dynamics, high radiation, skip entries, just to orbit the moon. Some critics say, we've already been there. This is a waste of time. Go straight to Mars. Others say, we need to practice on the moon first. Mars is 100 times harder. Which side are you on? Is Artemis a necessary step, or are we spinning our wheels? I genuinely want to read your take. Drop a comment below. This mission isn't just about survival, it's about connection. Apollo gave us grainy, black and white TV. Artemis II is going to give us O20, the Orion optical communications system. For the first time, we aren't using radio waves to send video. We are using lasers. This system can transmit data at 260 megabits per second. That is better than the Wi-Fi in most hotels. This means we are going to get 4K, ultra-high-definition live streams from the far side of the moon. Imagine seeing the Earthrise, that famous blue marble rising over the lunar crater, but in IMAX quality, live. That is the Apollo moment for the TikTok generation. And watch out for the proximity ops demo. Once they reach orbit, the crew will detach from the upper stage of the rocket. Instead of flying away, pilot Victor Glover will take manual control of Orion and try to fly back to the spent rocket stage. He will use it as a target practice to prove that Orion can dock with other ships in the future, like the Starship lander. It's a high-stakes video game played with a billion-dollar spaceship. Despite the risks, the heat shield anxiety, the radiation belts, the skip entry, the mood at Kennedy Space Center right now is electric. We haven't seen a crewed moon rocket on the pad in 50 years. When Reid, Victor, Christina, and Jeremy climb into that capsule this September, they carry the dreams of a generation that missed Apollo. Science is about managing risk, not eliminating it. NASA has checked the math. The shield has been analyzed. The trajectory is set. We are ready to go back. But orbiting the moon is just the warm-up. The real main event is landing. And for that, NASA is waiting on a completely different rocket, SpaceX's Starship. Is it ready? Or will Artemis III be delayed until the 2030s? That's our next investigation. Thanks for watching. The moon is calling. Keep looking up, and I'll see you in the next one.